Okay, alright. So, it's very simple. So, your muscle fibers are made of myofibrils. The myofibrils are made up of contractile subunits. I'll just show you how a contractile subunit works. So, here and here, these are, okay, I forgot what they're called.
No, I unplugged your Ethernet, but your computer defaulted to fucking Wi-Fi.
Dumbass.
That's baller as
Alright,
fuck.
so, these form the boundary of our Z-disc. So this is our Z-disc. This is the maximum length that the muscle fiber will get to. It is held in place that way by a couple of elastin fibers. All right, so we then have. Good work, whoever's taking notes furiously.
It's Matt. Good. It's
Oh,
Matt.
We
That's
then
good.
have two interacting filaments.
you know what? You're right. I should take notes.
But
This looks
Ben,
like an
where-
abacus.
Where are your
Mitchell, I was asked to explain. I'm just explaining. Okay.
Yeah,
Alright,
Mitchell,
fine,
get out
okay,
of here.
okay.
Yeah, I want to hear this.
All right, can you start from the beginning again? I wasn't
Please shut
taking
the fuck
notes.
up.
We should get Oni in here too. This is what he wants to do, right?
All right.
He's gotta know how muscles work.
We have these red ones are troponin, which is the kind of anchor points along an actin cytoskeleton. Together, they're called tropomyosin. And then this in the middle, these are myosin, right? So the interesting thing is that on the ends of these myosin thing, there's two little, or well, many little heads, right? So a good way to imagine it is along the tropomyosin fibers, it's basically like a bunch of gears, like tiny teeth for a gear, and each step, these one of these myosin heads will literally go, swing forward, latch onto a gear, and then it will pull the entire myosin fiber forward. And that's done through like 4 or 5 non-covalent interaction steps, mediated by the presence of ATP and calcium.
I have a question.
Yeah.
If they move fast enough, will it be like a chainsaw and totally rip up the red part?
Yes.
Oh, that's huge.
That is very, very much a thing. These, like when people, like they rend muscle from bone type shit. Yeah,
Oh, yeah. Oh, okay.
if you dump enough calcium and ATP into this subunit, yeah, you will just absolutely shred your topomyosin, and then the myosin is just kind of hanging out like, the fuck do I do now?
Huh.
Nice.
So you gotta be careful. Anyway, so one of these heads swings forward, it grabs, then another head further down, say this one, releases, it goes up, and then it then swings around, it grabs here, and it keeps pulling forward. So if you then figure that there are these heads on both sides, they can go, grab, and they basically squeeze the two green sides here in towards the center.
I have a question.
Yeah,
Why are some of the heads dots, but the other heads are lines?
fuck you.
Are they different?
No.
Step outside the class.
Okay.
It's a different brush size, Matt.
Go to the principal's
You're
office.
going to fail this semester of bioinformatics.
I was just wondering. I'm sorry.
Yeah, don't wonder on these parts.
Unless you're right, like me. But I'm awesome, so understandable, really.
Okay.
So let me find a good diagram of the power stroke cycle. Here we go. Fuck, I didn't work well. Alright, so here, this is our myosin head. This is the active site where it is going to bind right here. You can see we have ADP and phosphate here, right? So what happens is calcium comes in, it binds to this troponin site, and when that happens, it introduces a conformational change, slightly opening up this fiber. The myosin head can come in, which you see here. It binds to the troponin, and then this ADP and the P. No, just the ADP dissociates from the myosin head, and then that induces a conformational change in the myosin tail, which then causes it to contract. As you can see here, it curls upwards and pulls the entire fibril. But if this is happening on both sides, you have to remember that this represents the outside being pulled in. That would be to the left in this case, or this to the right, depending on your frame of reference. Then this releases from the sarcomere after that, in response to sodium, I think. I forget. I doesn't matter. No, that's from the phosphorus leaving. Anyway, then it goes, relaxes to this state. An ATP comes along, binds itself. The dephosphorylation reaction powers this to come and connect to another sarcomere after that has been had its fucking connect to another troponin after its calcium induced shape change and all that happy horse shit. So you duplicate that out a bunch, and that's how a muscle goes from relaxed to contracted. And then contracted to relaxed is just the opposite. So there you have it.
Is this going to be on the test?
Yes.
Can we do a presentation night where you guys talk about all the fun things you're learning in college?
No.